Hello, welcome back. We are on the last week of our lessons. This is module 36 and we are towards the end of this course. So, we have finished quite a bit actually, and now we are into the first order predicate logic, where we are going to look into just the bare overview of the syntax of first order predicate logic, and we are going to learn about predication in a slightly different way. So, today's module I introduce to you what this first order predicate logic is and what are the most elementary syntax in this. Syntax, as you always know, is the way to learn how this logic moves. What are its priorities? All of this you shall be able to find in the syntax itself. So, you can say that this is our introductory lesson to first order predicate logic. You are going to see some many similarities in the way the categorical logic thinks, but that was the whole idea, to give you a sort of have the categorical logic as a preamble to understand first order predicate logic. Why are we going towards first order predicate logic? Again, we need to remember what I told you is that we left propositional logic behind, right, and the whole idea was to get inside the structurally simple propositions. And I said there would be two ways to look into the insides of the structurally simple propositions. One is the categorical logic way or the Aristotelian way, another is the first order predicate logic way. Okay. So, now we stand in the first order predicate logic, and we are still talking about how to analyze the structurally simple propositions. What was the problem with Aristotelian logic? Why couldn't we stop there? So, let us just barely touch upon that. See, Aristotelian scheme is a wonderful scheme. It gives you statement forms of four kinds. It tells you the structural property, the formal validity and formal invalidity, and all that is good, but it looks in a certain way at propositions, and that is what makes it a partial theory. It only looks into certain subset of propositions, namely the categorical propositions, and that too it tries to only approach the categorical proposition analysis through predication in terms of class inclusion or absence of or negation of class inclusion. So, that is the lens that it uses, and that becomes its definite limitation, because there are so many other kinds of predications also possible. So, this is the reason why we are leaving categorical logic behind, and then we thought about supplementing our understanding by the first order predicate logic also. When you are in predicate logic, we are still talking about predication, which I have touched upon in the categorical logic also. Predication, whenever I use this word, I told you it means ascribing a property to some things or objects. So, you are assigning properties to some objects and things, and this is exactly what categorical logic did, except they treated the properties also as a class, the things and objects also as a class, which it is not going to happen in this kind of predicate logic. For example, take a look into this. This leaf is green. This is the object which has the property of green, but this object, first order predicate logic will tell you, need not be a class, need not be seen as a class. It is an individual leaf, a very particular leaf, just like this pen is a very individual and unique object. It is a particular object. We do not need to think the pen as a class by itself in order to understand the properties that it has, in order to predicate some properties to this. For example, this redness that this pen has, in order to say that the cap is red, we do not have to go into class terms inclusions to talk about that this pen is red. This is what we are learning from first order predicate logic. So, how are we going to understand it? What is our take on this? This is what we are discussing. But first of all, this is what we touched upon, that in order to approach predications of this kind or any kind, this leaf is green, leaves are green, whichever way you want to go, predicate logic says it is not necessary that we have to always use the lens of class relationship or membership in a class. But all that said and done, we are still into the deductive system, and what you will find is that we are going to carry everything that we have learned in the propositional logic and will bring them here, but first order predicate logic is going to have its own unique kind of syntax. The symbols are going to look a little different, because apart from the proposition symbols, you are going to also have predicate symbols. Now, this is a new. Earlier in propositional logic, you saw only the proposition letters. Now, you are going to see some symbols which are going to be predicate letters also. So, naturally, your propositions are going to look kind of different, right. So, be prepared to appreciate that difference. Plus, there is going to be another kind of entity, operators, called quantifiers. What they are, I will explain as we go along in this next module and so on, but we are just learning the ropes here, and the syntax I said is going to look a little different. Now, let us proceed with the syntax. First thing in a language is the constants, the names. So, the individual constants for first order predicate logic, they do have a place. Their function is to pick up unique particular objects from the domain. In a way, the individual constants work like proper names. You know, when you are sitting in a class, a whole lot of people, but when your name is called, you respond, isn't it? So, in a way, your name picks you out from the entire classroom, and that is why you respond to it. So, similarly, think of the individual constants as proper names of things in the domain, in your domain where you are working. So, individual constants, they are going to have a fixed constant reference tied up to some particular thing in your domain. Now, visually they are going to be lowercase alphabets. Okay, lowercase. Now, there is case sensitive here, lowercase letters. Now, you may have subscripts, numerical subscripts with them, you may not have, but it has to be lowercase letters, alphabets, suitable lowercase letters. Let me show you some. For example, if your domain includes Aristotle, then you might think of assigning this small a, lowercase a, to Aristotle. So, whenever a is used in your logic, predicate logic, this refers to Aristotle and Aristotle only. Similarly, suppose Mount Everest is there in your domain, and we have picked E, lowercase e, to refer to Mount Everest. So, the reference remains fixed, and whenever you are using E, it will pick up only Mount Everest and nothing else. This leaf, so many leaves are there. So, this leaf, let us give it a subscript of numerical subscript. So, L2, arbitrarily speaking, you can call it L14 if you want, or L1, anything. As I said, you can even call it just L, that is also okay, but in this context, this reference will remain fixed, and that is the job of what we call the individual constants. So, please understand the term very well. Constants means reference is constant, fixed. Individual, as in this will pick individual objects or things, entities from your domain. okay, individual, as opposed to groups, classes, large clusters and so on. And then we come to discuss about the predicate symbols. Now, this is something new, so pay some attention to this. See, we are going to deal with properties that we will predicate. For example, being green. This leaf is green. There is being green predicated to this leaf. Okay, this is how it is going to read. So, what we will do is to use capital letters, assign capital letters, suitable capital letters to predicates. Remember, we used to assign capital letters to structurally simple propositions and propositional logic. Now, here the capital letters are going to refer to only to predicates or properties. And this should also tell you that the emphasis is on more on the properties or predicates rather than on the individuals, because this is where you can see the case sensitivity showing up. The uppercase or the capital letters are being assigned to predicates, and they hold primary positions in our logical consideration. We will show you how to read sentences. So, before things the predication comes, the predicates come before the things, and that is known as prefix notation. Okay, I will show you how to do this. Let us take an ordinary proposition: Aristotle is a philosopher, right? And this is what is the sequence. But in first order predicate logic, the best way to read that would be to start at the property. So, you are reading, and this reading I think you should practice this also, because that is the key to understand the syntax of this logic. Predicate logic reading of this proposition is going to be this, that being philosopher is a property predicated to Aristotle. Take a look. So, primary position is that of the property, which is being predicated to the individual who is Aristotle. Get it? Now, let us bring to our mind that we have decided to have capital letters for the property, and for the individual we have the individual constant, right. So, once more reminding you, being a philosopher is, let us say, capital P, and Aristotle is lowercase a. Now, Aristotle is a philosopher is read like being philosopher is a property predicated to Aristotle, and the symbolization would look like this. P comes first, that is the prefix notation I was talking about, followed by the lowercase a. This is the reading of Aristotle is a philosopher. Okay, a philosopher, being philosopher is assigned or predicated to a. Okay. So, this is what this propositions are going to look like. That is still a structurally simple proposition, but notice that we have gotten inside it and we have found the predication inside that is happening between an individual and a property, but no class reference so far. Let us take another example. For example, we saw that this leaf is green, fine. So, being green is G and this leaf is L2, we decided arbitrarily. So, the translation of this is going to be what? It is going to be G L2. G is first, being green is predicated to L2, which is this leaf as in this leaf. Okay. Now, notice that each of these propositions that you have seen so far, as I said, are structurally simple proposition. What we have done is to use the lens of predication to find logical information inside them. So, we have analyzed them, the structurally simple proposition. We have opened them up and we have tried to look inside them, but the lens this time is not class inclusion, but that of predication. Our next stop is to know about the individual variables. Individual variables. See, again the reference is to individuals, individuals as in particulars, okay, particular things, but variables, okay, as you know, variables are placeholders. So, the difference between individual variables and individual constant is the constant is like a name, it is attached to one specific particular thing throughout. Individual variables is different, they work differently. They refer to unspecified individuals. You are referring to individuals, but not necessarily to one particular one. Okay. For example, when you talk about some people, okay, you do not have any one particular in mind, but you want to keep the reference slightly unclear and unspecified. That is the time to use the individual variables. When you are using individual variables in this logic, remember, use lowercase alphabets from the end of the alphabet series. So, x, y, z, u, v, and so on and so forth. So, towards the end of the alphabet series, choose lowercase alphabets to represent individual variables. I will show you enough examples of when to use the variables and how to use the variables. In fact, you will find that quantifiers cannot work without using the individual variables. But at the moment, keep in mind that individual variables do not have any fixed reference. They are like placeholders. So, they can refer to unspecified individuals, and the only thing is that the variables are going to be chosen from the end of the alphabet series, but lowercase. Okay, so we have covered individual constants, and then we looked into the predicate symbols, and we also saw the individual variables. Now, notice that so far we kept it rather simple, but there are predicates which deserve and require more than one constant or variable. These are called n-place predicates, n for any variable number of symbols. So, it can be 2-place predicate, it can be 3-place predicate, and so on. But the point is that they require more than one. Their nature is such that they require more than one constant or variable, and they are in ordered sequence. It is not necessarily haphazard. So, these are going to be sort of like ordered n-tuplets. So, n-tuples and in proper sequence. So, order n-tuples sort of like. Take a look, for example, is greater than, is greater than. That is obviously a 2-place predicate. Something has to be greater than something else, right. So, that is a 2-place predicate. So, you are going to need either 2 constants here or 2 variables here, correct. For example, 100 is greater than 90. Now, that is a constant. 100 is, you need a constant for that, because 100 is one specific number, 90 is one specific number. They are like names of numbers. So, we have chosen h and n, h for 100, n for 90. And this is the representation in first order predicate logic of this English sentence: 100 is greater than 90. The being greater than is the G, is greater than. Okay. So, this is going to be put like this, that we can put it like so. X and y are variables. So, for any x y, x is greater than y, and that is represented in g x y. If that is the case, then this is our translation of 100 is greater than 90. Here is another example: between, in between. In between requires 3 terms, 3 constants or 3 variables. Something has to be in between this place and that place, or this thing or that thing. So, 3 different individuals you need to specify. So, here is the predicate letter, for example, B, and x, y, z, that is your variables lined up, where this means x is in between y and z, fine. Given that we are trying to represent Kharagpur is in between Kolkata and Bhubaneswar. Kharagpur is in between Kolkata and Bhubaneswar. So, Kharagpur, let us take that is a place, right, that is the name of a place. So, we need an individual constant. Kolkata, Bhubaneswar, we need individual constants to represent this. So, your translation becomes B G for Kharagpur. Kharagpur is in between. That is what I said, it is a ordered sequence, you can't change it, you can't bring Kolkata and Bhubaneswar before. So, Kharagpur is between Kolkata and Bhubaneswar. G represents Kharagpur. So, that is how we are going to handle this kind of n-place predicate symbols. There is also, as I told you, that we are carrying everything back from propositional logic. So, you are going to see truth functional statements also in first order predicate logic. Let me show you. For example, think about this sentence here. Aristotle is a philosopher and he taught Alexander the Great. Once more, Aristotle is a philosopher and he taught Alexander the Great. Now, read the sentence carefully. It is an and sentence, yeah, but the conjuncts, now this you understand, this is going to be our dot, correct, but the conjuncts, take a good look into the conjuncts. Aristotle is a philosopher. Do you now see the predication happening? Being philosopher is predicated to Aristotle. There is that has to be there. And look at this conjunct, he taught Alexander the Great. So, if we have a property called x taught y, so that would be the predication that we can now assign to Aristotle, where Alexander the Great is a name also. So, we need a constant for that. Okay, let us see what we have. Suppose we have the symbols lined up like this, where Aristotle is A, Alexander the Great is small g or lowercase g, Px stands for x is a philosopher, Txy stands for x taught y. Okay, then again we have the two-place predicate where this is expressed by the variables, but we know what we want to do. What would be the translation here? Aristotle as a philosopher we have done, that is your capital P followed by lowercase a, right, we have done that. This is who taught whom, so T A G, right, Aristotle taught Alexander the Great. Okay. Now, let us see, the translation therefore is going to be something like this. One conjunct is Aristotle is a philosopher, this is where Aristotle taught Alexander the Great. Okay. And look at this dot, that is your and. Note that this sentence, which may not look to you very familiar if you are still in the propositional logic phase, this is a first order predicate logic sentence, but it uses the truth functional connective dot. Not only that, it is a truth functional compound. It is going to follow the truth table of the dot. It will be true only when both the conjuncts are true, false in every other case. Get this? So, once more remember what I said, that predicate logic will include truth functional compound statements also, like so. Okay. So, this was an example, but we will see many more as we go along in this. Now, finally, we have now a slightly better grasp of the syntax, but one question might come to your mind is that why is it called the first order predicate logic? Predicate logic we understand because it is all about predication, but why is it called first order? Now, that answer from my side, I am going to keep it rather short, but it should be also satisfactory. Please note the first here stands for being the most elementary, all right. So, the very first in the order of predicate logic, this is the first order predicate logic. So, remember the first means here the most basic or the most elementary kind of predicate logic. Elementary in what sense? Elementary in the sense of predication. It is the it deals with the most elementary kind of predication, which is what? Which is about properties being predicated to things or objects. Okay, remember, as I said, this pen, right, this pen, or if you want the same red pen, okay, here is the red pen, or the pen with the red cap, fine. Now, this pen is an object to which properties belong. So, we use the language to talk about predication to this thing in this logic. For example, the cap of this pen is red, the body of this pen is somewhat blackish. Okay. So, I am using predication language to characterize this pen. As long as predication remains at this level of things and their properties, we are still in the first level. Whereas, there can be higher level of predication where we speak about properties of properties, okay, or properties of properties of properties. So, the order of predication most elementary is things and properties, but then it can go into more abstract level where even properties of properties can be talked about, their quantity can be talked about, and so on. So, this is not our concern. We are here and we are into first order predicate logic, all right. So, this is where we are going to close the discussion today, but we are going to learn more about this logic in our next module. Thank you very much. Bye bye.